Hello, Trig 8.8. This is getting us toward the end of our chapter. 8.8 is about a thing called mathematical expectation. So basically, this is what they've trying to lead us toward, is trying to just decide, is this a good idea or a bad idea? So the formula for mathematical expectation is this crazy symbol, which is the Greek letter sigma. Sigma means the sum of. So today we're going to have to add up a bunch of different scenarios. But we're going to add up every scenario we can think of a probability of something happening times the payoff. If I were going to try to give you a real world example of this, you go to across the street, you see traffic coming, and you try to weigh out, if you're a reasonable human, what's the probability the truck is going to hit you versus the payoff of saving 5 seconds. So you might think, probability that truck is going to hit me is high. The payoff if it hits me is death. Probability I beat the truck is low. My payoff is I gain a few seconds of time. I think I'll weigh that out, and the probability and the payoff is really not worth it here to me. In a more mathy sort of way, warranties operate on this. Every time you go to a store and you buy an appliance, if you're with your parents when they do this, you get to the checkout and they always want to sell you the warranty. And sometimes I'll go off on a little rant with the cashier over the fact that if they're selling me the warranty, it can't possibly be good for me. Because if it were, they'd go out of business. They're only selling me these warranties to make money on me. The probability of me breaking my item is actually low. The probability of them paying off this thing to me is low. And the payoff just isn't high enough for me to do extended warranties. But it's just subject for another time and place. But you always, when you're making decisions, you need to weigh out what's the probability that this is going to go one way or another, and what's the payoff when it does. The bad news in the homework tonight is the probability could be literally from any lesson. They could go back to the dice day 1, or a deck of cards day 2, or P's, or C's, or ands and ors, or yesterdays, or really any day. The probabilities could be using any of the lessons we've learned. That's why they saved this till the end. The payoffs should be explained to you in the stories. So the first problem I'm doing is just a book story. So I work from page 263. It says, you're at Playland playing the basketball toss game. It costs you 50 cents to play. You shoot 3 balls. If you make no baskets, you get nothing, and you lose your 50 cents, of course. If you make 1 basket, you win a paper hat worth a nickel, but you're still out your 50 cents. 2 baskets get you a stuffed animal worth 60 cents, but you paid 50 to get your 60-cent item. Making all 3 baskets wins you a doll worth $2.50 that you paid 50 cents to play. But they say the hoop is so small, your probability of making any one shot is only 0.3. What's your mathematical expectation for this game? Well, the first thing I'd suggest is lay out your different scenarios in English. So the ways that this game could go is you might make no shots, you might make 1 shot, you might make 2 shots, or you might make 3 shots. That's how this game could play out. There's 4 different types of scenarios there. All of them involve 0.3 in some way, because that was the number they mentioned in the sentence. But then you have to think through, what day's worth of lesson of probability is this? That I'm going to make 0 shots out of 3, or 1 shot out of 3, or 2 shots out of 3, or 3 shots out of 3. And hopefully that's feeling a little bit familiar, because this is something we did yesterday. So what's going on here is you have a chance of success of 0.3s, which means you have a chance of failure of 0.7. And then we had C's involved yesterday. So if we're going to make no shots, we'd go 0, 1, 2, 3. if we're shooting 3 shots, we're 3C, 3C, 3C all the way down, and we're making 0, 1, 2, 3, which means we're missing 3, 2, 1, 0. We'll punch in those probabilities, and this will turn out a .343, a .441, a .189, a .027, and if you think through your experiences at County Woods or arcades or wherever you may go, the chance that you hit the jackpot is not ever going to be very big. That's why they're in business still. The chance of you failing is fairly high. What we need to do is take all these probabilities that we've learned how to do all these different days, and now multiply each one by its payoff. I'm going to take you through a longer way first that makes more sense, but then I'll shortcut it a way that I would probably prefer to do myself. Okay, but if we think about the payoff here, we made no shots, we got nothing, but we paid 50 cents. So you can subtract 50 cents from that. This, we had the nickel hat, but we paid 50 cents for it. So we're out 45 cents of value. There was a 60-cent doll here, but we paid 50 cents for it, so we could get a 10. And then there was a $250 grand prize, but if we subtract $250, we'd be up $2. What we would look to do is all those multiplications and add them all up. And it shouldn't be a shocker that this turns out to be negative. It's negative 29.7 cents because you're losing money playing games when you go places. That's why these businesses exist. Every game at the casino would have a negative expectation for the casino players. That's why casinos make millions and billions of dollars. Why do people go to casinos and throw their money away? I'm not quite sure. But every game is rigged by the casino. They set the probabilities by creating the games. They set the payoffs by setting up the rules. They aren't going to create anything that's going to lose them money. So individual people are going to win once in a while, but on balance, the casino is going to rake in the money. I would highly advise against casino gambling in your lives if you actually like, having money. If you happen to be a casino owner and don't have a problem with the morality of that, in the strictly financial sense, being a casino owner is quite a lucrative business. So if you don't care about the morality of making money over gambling issues, maybe you'd like to be a casino owner someday. If I did a twist on this question and I asked you what Playland's expectation was, if I asked you what Playland's expectation was, these negatives would turn positives, and the positives would turn negatives. Because from Playland's point of view, this was quite positive. When you missed all your shots, they kept your 50 cents. This was the negative for them. When you made the shots, that's where they went negative. Playland's expectation would be the same number, but positive. And that's part of my rant sometimes when the cashiers of the store continue to press me on this issue is every dollar the store makes on my warranty is a dollar I lost. Like the numbers are equal, but we're on the wrong side of the table. The warranty seller is always making money. The warranty buyer is losing their money. I promised you a quicker way to do this, so here's a quicker way to do this one. Anytime there's a game where you pay to play every time, instead of doing a subtract every time, you could wait and subtract at the end. So what we had going on here, to do this a shorter way, here you were getting nothing. So don't even worry about that whole line of math. That could all be useless to you. Here you were getting a nickel. Here you were getting 60 cents. Here you were getting $2.50. You could add up just those 3 levels, ignoring the 0 level, and that would get you a 20.3 if you want to try it. If you want to trust me, that'll be what it'll be. When you're all seemingly done, you just have to remember to subtract off the 50 cents. Because this 50 cents wasn't like a maybe, maybe not. You're guaranteed you're out 50 cents. So you could do the math on the maybe, maybe not stuff and subtract the 50 cents at the end. Here's a simpler version of the same thing. This takes us back to like day 2 of the chapter, playing cards. So I'm gonna get you to pay me $1 to pick a card out of the deck. And I'm gonna give you $10 if you pick an ace. That sounds tempting. Same reason the daily number of the lottery seems tempting. If you have relatives that play the Powerball and stuff, God bless them, I hope they win, but realistically they'd be better off just flushing their money down the toilet. If they're paying that for $1 every day, just every day take like 50 cents, flush it down the toilet. And then the math is a little bit better on them just taking 50 cents and just chucking out their car window every day than paying $1 to play those games. But if they have fun playing the games, hey, go for it. But mathematically speaking, instead of paying $1 to play, you'd be better to just throw 50 cents like down the sewer. But anyway, you're going to pick a card, you pay $1, you get $10 if you get an ace. I would first again recommend, just in English, write down what could happen here. This is a simpler question. There's only really 2 scenarios. You might pick an ace. Or you might not. That's it. That's your 2 basic options. You either are picking an ace or you won't. That's the whole premise of the game. So if you picked an ace, the chance of you picking an ace would be 4 aces in the deck out of 42 or 52. The chance you did not pick an ace is 48 out of 52. And then I'll take you on a longer road, but a shorter road applies on this question too. There's a shorter road every time you pay to play the game. Well, let's go long road. So if we're picking an ace, your payoff is not actually $10, it's actually $9, because I'm keeping your $1. You pay me $1, you pick the card, I keep the $1 forever no matter what. You only get the 10 if you get an ace, so really you're only making $9 there. There's a hidden cost. You don't pick the ace, you're negative $1. You pay me $1 and you're out. Do those 2 things, add them up. Math on this from your point of view would be negative 23 cents. If we played this game from my point of view, the 9 is negative, the 1 is positive, it's still 23 cents, but it's positive because I'm stealing your money 23 cents at a time on average. If you want to go a shorter way on this, because it's pay to play, this choice where you got really nothing new, you paid $1 and it was gone, you could erase that whole level, just do this level times the $10 you get, do the math on that to show you 77 cents, and once you're seemingly done, just remember to subtract $1 because you paid me the $1 no matter what. The only way that shortcut doesn't work is if you don't pay no matter what. So if we change the game, you're going to pick a card, you pay $1 only if you lose, but you get 10 for the ace. Now we need this level back in there. And if you pick the ace, it's a 10, a true 10, because you're only paying for losing opportunities, and then the losing opportunity is negative 1. We would need to add those 2 levels together. I don't know what that is because I just made that question up on the spur of the moment. But this times this, adding that times that, it is what it is. You're still losing, but not as bad. You wouldn't be losing 23 cents anymore. You'd be losing, I don't know, something probably in the teens of cents. The homework, we're here a couple days. There's a 1 to 8 that is the first day's worth. And then there's a 9 to 15 that's the second day's worth. I need to get you started for you to have success on 14. How much? We have 5 minutes left on this video setting, so I think we table that. I'll make another video another time to get you started on 14. But you should be able to be semi-okay 1 to 8-ish, and then on you go. Quick skim of this page. The first couple, they've already done a lot of the work for you. what they've done on the first few is they've already given you like a table with probabilities and payoffs in the table. So if you start the first few and you're like, how do I even figure this out? One is like the one I did here actually, but 2 and 3, they gave you a table where they tell you the probability, they tell you the payoff, and all you have to do on 2 and 3 is like this times this, plus this times this, plus this times this, and go through your table doing that. 4, you have to start figuring out things on your own again, and on down. But we're 1 to 8 for a day, 9 to 15 for a day. If you have trouble, email me or join one of the Zoom sessions and we'll work them out. See ya.